वेलकम स्टूडेंट्स। आज हमारा आईसी इंजन का 16th लेक्चर है। पिछले लेक्चर्स में हम लोगों ने कंबस्जन, डेटोनेशन, फ्लेम स्पीड ये सब कुछ पढ़ लिया है। ठीक है, इस लेक्चर में हम लोग देखेंगे कंबस्जन चैम्बर्स फॉर एसआई इंजन। ठीक है, ज़्यादा डिटेल में नहीं, ब्रीफली देखेंगे कि व्हाट आर द रिक्वायरमेंट्स फॉर अ गुड कंबस्जन चैम्बर in case of SI engine. The combustion chamber design is a very critical thing because engine performance and detonation or knocking tendencies of SI engine is largely depend on the design of the combustion chamber. The design steps involved the shape of the cylinder head and piston crown, the location of the spark plug, and the location and size of the valves, both inlet and exhaust valve. Okay, so these things are very critical for engine performance in case of SI engine. Okay, what are the basic requirements for a combustion chamber to be a good combustion chamber? The first one is, you know better, it should provide a good combustion chamber should provide high power output. Okay, power output should be high enough to fulfill the engine requirements. ठीक है, the second one is the high thermal efficiency. Okay, because one should always want a SI engine having a high high thermal efficiency as well as high power output, low SFC. Okay, specific fuel consumption should be low, means fuel consumption per unit power should be low. Some other requirements are, engine should be smooth and quite noiseless, as noiseless as possible. Okay, and the final one is, it should capable of reducing exhaust pollutants. Clear? So these are the basic requirements of a good combustion chamber. So the design principle for a combustion chambers are, the designed combustion chambers should be having high volumetric efficiency. Okay, high volumetric efficiency means it must have more charge per stroke as well as large valve heads. Clear? Second one is the minimum path of flame travel, because knocking depends on the flame travel path. So therefore it should have minimum path of flame travel to reduce knocking tendencies in case of SI engine. For that parameter, the engine combustion chamber should be compact. The third one is the provision of minimum heat loss around the spark plug. If the heat loss zone around the spark plug is large, then the flame should not be sustainable. So therefore spark plug will be located in the minimum heat loss zone. Okay, and for fulfilling this purpose, the spark plug should be placed near the exhaust valve. Clear? Next design principle is, it should have maximum thermal efficiency. How one can get maximum thermal efficiency? By increasing the compression ratio. Earlier you have read about HUCR, highest useful compression ratio. The combustion chamber should be designed in such a way that it should provide maximum thermal efficiency. This can be achieved by employing the highest compression ratio without knock. Next is the exhaust valve location. So you know that the exhaust valve location is very critical in case of SI engines. if the exhaust valve location is not proper, then there is a possibility of knocking or detonation. Okay, so the exhaust valve location should be provided in such a place that it should not act as a hot spot in the end gas region. Clear? Second point is the exhaust valve should be placed near the spark plug, because if there is a heat loss from the spark plug, if the heat loss from the spark plug is more, then the flame should not be sustainable. Okay. One is valve head diameter is kept small with high lifts. Valve head diameter is kept small with high lifts so that it should not act as a spot, as well as it should provide maximum charge per stroke. The design involves three types: shape, location of spark plugs, and location of valves. Shape of cylinder head and piston crown. Depending upon that, cylinder head piston should be either flat or hemispherical or like this curved. Okay, and the piston crown should be of wedge shape. Wedge shape means like that, or some smooth curved wedge shape like this. Okay, and depending upon the location of spark plug and exhaust valve, combustion chambers are classified as T head type, L head type, or side valve, I head type or overhead valve, and F head type. Okay, these are the four types of combustion chamber depending upon the valve location and spark plug location. Okay, so let us see one by one. So what the first one is the T head type. First combustion chamber which was designed earlier was the T head type. Okay, look at here. The combustion chamber head is flat. Okay, combustion chamber head is flat. Spark plug is located near the exhaust valve. Okay, spark plug is located near the exhaust valve, and inlet valve and outlet valve are located in opposite way. Okay? So this was the first combustion chamber which was designed. Okay, since the flame travel distance is very long, flame travel distance is very long, therefore knocking tendency is high in this type of engine. First disadvantage of T type combustion chamber is its flame distance travel is long. Okay, second one is, as the inlet and exhaust valve as the inlet and the exhaust valve are located diagonally opposite, so you have required one should require two camshaft. Okay, two camshaft to operate the inlet as well as exhaust valve. Okay, and operation of two camshaft will be a tedious task, as well as it will not good from manufacturing point of view. So these are the disadvantage. It was the first combustion chamber which was designed. After T head type, the next combustion chamber was the L head type, or other name is valve in block. Okay, so the shape itself tells it is a L shape. Here you see that the inlet as well as exhaust valve are on the same side of the engine, on the same side of the combustion chamber, not as in T shape it was in the opposite side, but in L shape it was on the same side. Clear? So as you know, in T shape you require two camshafts to operate inlet valve and exhaust valve, but in case of L head type you required only one camshaft. One of the disadvantage will be resolved. So L-head types provide two valves on the same side of the cylinder, and valves are operated by single camshaft, thus reducing flame travel. Okay, it has low turbulence. It has two right angle bend. First, from inlet valve to combustion chamber, from inlet valve to combustion chamber. Second, from combustion chamber to exhaust valve. Okay, so it has two right angle bend, therefore turbulence will be somehow low. Third one is low flame speed. Because of these bends, the flame speed should be low, and as the flame speed should, is low, then the engine should prone to knock. So these type of L head type of engines are not preferred for high compression ratios engine. This is the advantage and disadvantage of L head type. The construction is shown in figure. So next type is I head type or valve in head. It is called as valve in block. It is called as valve in head. This type the valves are located in the cylinder head. But here earlier I was told that it was wedge shape or smooth wedge shape. I head type the valves are located on the cylinder head. Overhead valve engine is superior to a side valve or a L head engine at high compression ratio. Third one is less flame travel length and hence greater freedom for knock. Look at the position of spark plug. So as the position of spark plug is in the cylinder head, therefore the flame travel distance is low. If the flame travel distance is low, you know that there is a less tendency of knock. Fourth one is the high volumetric efficiency from larger valves or valve lifts. The lifts are high, then the space around the valves are more, so it will induce more charge to the cylinder, therefore it will have high volumetric efficiency. And the final one is the F head type. So the F head type, in F head type combustion chamber, okay, look at the position of inlet valve and exhaust valve as well as spark plug. Look at the profile of the piston head. It is a double base shape. So the F type of valve arrangement is a compromise between L head and I head. Clear? In F type combustion chambers, one valve is in the cylinder head and the other cylinder block. The flame travel is very short, and the main disadvantage of this type is that the inlet valve and the exhaust valve are separately actuated by two cams mounted on two camshafts. Because these are either side of the cylinder, therefore you require two camshaft. Okay, as in T head type. So nothing new in this F head type. It is in between L head and I head. Also, it has some feature of T head. Exhaust valve and inlet valves are in opposite directions or on two different directions. So you require two camshaft. Okay. So these are the portions of L head. This is the portion of I head. Okay. So it is in between the L head and I head. This is all about the combustion chambers. Now combustion in SI engine is finished. In the next lecture, we will see combustion in CI engines.